In this video, we will discuss the idea of the universal set and Venn diagrams. To begin, let's consider the following example. If we took a poll of our math class, and in that poll we determined what type of music everyone prefers, some people might prefer classical music, others might prefer contemporary music. Based on what has been outlined so far, think about whether the teacher would be considered in this discussion based on how we described it in what was highlighted in blue. I encourage you to pause the video now, reread the setting of the problem, and then consider would the teacher be included. Unpause for the rest of the discussion. At the very introduction of this problem, we said consider all the students in our math class. We didn't say consider every person in our math class, but we specifically said consider all the students. So from that beginning point, it made it clear that we were only polling the students. So because of that, we would say the teacher is not considered in this discussion. Next, let's answer the question, would somebody in nearby classrooms be considered in this discussion based on how we described the example? Again, we would say no. Specifically, we made it clear we're not just interested in students, but we specifically want the students in our math class, not students in general, not students nearby, only the students who are in our math class. The point of these two questions was to show that not everything or everyone is considered an element of every set. Whenever we're talking about a set and we want to consider all the possible elements that belong to that set, we have a special name for all the things, people, or items that would be in the set. Particularly, the name for that is the universal set. So the universal set, often shorthand written as U, includes all the things under discussion at a given time. So in our previous example, the universal set would have been all the students in our math class. So any student who is in our math class is an element of the set. However, the teacher is not in the universal set, nor are students in other classes. So the only people we would consider in this set are the individual students in our particular math class. Now, as we think about various sets and their subsets and where elements are located, it can be very helpful to have a visual representation of the set. And in order to have a visual representation of the set, we are going to turn to Venn diagrams. And what a Venn diagram does is it clearly indicates what is the universal set, and then within that universal set, which holds all possible elements of the set, if there are any subsets, it indicates where those subsets are and if they have any overlap between them. So one thing to keep in mind, a benefit to Venn diagrams, is it will clearly show overlaps of our subsets at a glance. So let's look at our first example that includes a Venn diagram. Let our universal set U be all the students at our school. Within that universal set, we are considering subsets of the second year students and nursing majors. In the space below, draw a Venn diagram that describes the situation. Whenever you begin to draw a Venn diagram, always ask yourself, what's the universal set? So read through the first few sentences of this problem and think to yourself, what is the universal set here? How would you describe it? The universal set is all of the students at our school. So we begin by drawing quite a large rectangle. I really encourage you as you draw your Venn diagrams to draw them with plenty of space, because particularly later on we're going to be labeling them, there will be overlaps, and we want to have enough space that what we write in those overlaps is not cramped. So I begin by drawing a large rectangle, and in one of the corners, the location does not matter, but in one of the corners I label this as U, and it can be helpful to say in words, what is U? It's all the students at our school. So if somebody is a student at our school, they are within this set. However, if we think of all the students at our school, there can be subcategories where these 15 students have something in common, and these other students have something else in common. We can break down all the students at our school into further and further categories. Some of the categories that we were presented in this problem are the second year students, so students who have been at our school for 2 years. Another category is the nursing majors. And since it just says nursing majors in general, that's anybody who's declared a nursing major, regardless of the time they've spent at our school. So these are already students at our school, so they belong to the universal set. However, they fit an additional category, and we want to think about how we will represent that. So the first thing that you think about in terms of Venn diagrams when you're given subsets is you want to ask yourself the question, will these subsets overlap? Okay, so is it possible that an individual might be a second year student and also fit the classification of being a nursing major? What do you think about that, yes or no? Yes, there will definitely be some second year students who have declared their major as nursing. So with that in mind, we know that these two subsets will overlap some. The next question you want to ask yourself is, will they overlap completely? Is every person in one of the subsets in the other subset? Or are there some people who will be second year students who are not nursing majors? And will there be some nursing majors who are not second year students? And the answer to that question is yes, there will be people who do not belong to both sets. So there will be some people who belong to both. There will be some second year nursing majors, but there will be other people who are second year students but not nursing majors, so they don't need to overlap with the other set. And there will be some people who are nursing majors but not second year students, so they don't overlap with the other set. So then what we want to draw here is overlapping circles, but they still have their own separate sections. So I draw a rather large circle because I want to make it clear that we have enough space for our intersection. And since I know these two sets overlap, I need to draw my next circle where there will be some in common between the two. I don't want to draw the second circle out here because that shows no overlap, but we know there are some nursing majors who are second year. So I've drawn my two subsets and I've made it clear there's an overlap. Now we're going to label it. So we're going to let maybe S represent the second years, N represent the nursing majors. So we've got our second year students here, our nursing students here. And then to help us visualize the Venn diagrams, you need to make clear what are the sets and then where are the overlaps. So for instance, how would you describe the individuals that live in this section? Notice that these individuals are part of the second year group, but at the same time, they're also part of the nursing group. So the people in this section are the second year nursing majors. Now the nursing majors as a whole is this entire circle. But through the overlap, we've separated out all of the nursing majors and we've made it clear here are our second year nursing majors. And then everybody who's not a second year nursing major lives in this section. Okay. So visualize in your mind's eye what would be, or where would in this Venn diagram, all of the second year students? All of the second year students is this circle. Okay, now visualize where would the second year students who are not nursing majors be? Second year students who are not nursing majors would be here. Okay? Where would the second year students who are nursing majors be? Second year students who are nursing majors would be in this overlap. And now comes our final question to think about. Where would the students who are not nursing majors and not second year students be? So all the students who are not second years and they're not nursing majors. If you're a student who's outside both those categories, they would be in this outer section, still part of the universal set because they're students at our school, but they are not second year students and they're not nursing students, so they would have to be outside of those groups. So in a basic Venn diagram with two subsets, we have one particular section, 2, 3, 4 different sections that we need to understand, the ones who are outside. And with this, we're done because we finished our Venn diagram, we've showed there's overlap between the groups, and we've properly labeled it. If we were physically all in a class together, we would begin this next example with a quick poll of the class. I would ask the students, who in this class is in an English class? And you could just think in your mind's eye, some students would raise their hand. I would also ask the students, who in this class is in some science class? And as you can imagine, some students would raise their hand. And every time I've done this, there's always been some students who were in an English class and in a science class. So let's pretend we have that same situation here. So we're going to consider our universal set to be all the people in our class. Let E be the subset of students who are also enrolled in an English class, and S be the people also enrolled in a science class. So we begin to draw our Venn diagram by making a large universal set, so we have enough space to draw all of our subsets. We label it in some corner. And now we draw our subsets. And before you draw your subset, or your subsets, you always want to take a moment and ask yourself, how will these subsets interact visually? Will there be completely separate subsets in which there's no overlap? Or will there be some overlap so that there can be people in both groups? Or will they be completely overlapped, in which case everybody in the first group is in the second? So imagine back to our pretend situation. Our entire class has been asked, who is an English student? Some people raise their hand. Our entire class has been asked, who is a science student also? Some people raise their hand. And in our pretend environment, some people raise their hand for both questions. So with that in mind, should you draw your circles completely separate? Or should there be some overlap? Or should there be complete overlap? In the case since some people of both groups stayed behind, there should be just some overlap, but there should still be sections that are completely separate. So we'll draw our two subsets slightly overlapping. We'll label it E for the English students also enrolled in an English class, S for the students also enrolled in a science class. In our Venn diagram, I've now shaded a particular section. How would you describe the students who belong to this particular section in words? Because they're within the universal set, they're definitely students in our class. So they are students in our class. However, more particularly, we see they live outside of both the students enrolled in English class and the students who are enrolled in a science class. So this green section that has been shaded would be described as the students in our class who are not in an English class, and they're also not in a science class. Now in your mind's eye, identify the section in the Venn diagram that would represent the students who are in a science class, but not in an English class. So they're in the science class, but they're definitely not in the English class. So these are the students who would be in a science class, but not in English. Next, identify what section would have all of the students enrolled in an English class. Finally, what section of the Venn diagram would represent those students who are enrolled in both an English class and a science class at the same time? So we practiced a bit identifying what the different sections represent. However, the problem was completed whenever we drew our properly labeled Venn diagram, and we showed that the two sets should have some overlap. Now that we've introduced the idea of how to draw a Venn diagram, we're going to begin to talk about some certain things called set operations. And the first of these set operations is the complement of a set. So consider our universal set. We have a certain set and there's only certain elements that we're considering. Let A be a set that lives inside of U. So with this in mind, we know A is a subset of U. Remember that subset has a particular definition. This was introduced in a previous section of our notes. But something is a subset if every element of the smaller set belongs to the larger set. So A lives completely inside of U. The complement of set A is defined to be all the elements that are in the universal set, but not in A. So it has to meet two things at the same time. First of all, it has to be in the overall universal set. And secondly, it can't be inside of A. So whenever we talk about A complement, we're saying everything except the elements of A. Let U, our new universal set, be comprised of the elements A, B, C, D, E, F, G, and H. And let A be a subset of U, where the elements of A are B, C, and F. Notice every element of A is an element of U, so we definitely have our subset. And we're asked to find A dash. Now A dash is the notation for the complement of A. Okay. So to find the complement of A complement would be the set of all the elements that are in the universal set that are not in A. So the way that you would begin writing this down is you would look at the elements in A. B is in A. Well, then we do not want to include B in the A complement. And I should have written this with a dash there. C is also in A, so it should not remain in A complement. F is in A, so it should not remain in F complement. So then I'm going to include only those elements that do not belong to A. So A complement would be little a, D, E, G, and H. So all the elements from the universal set that were not also a part of A. What if I introduced a new subset B? And I said B is the elements D, G, and A. And then I asked, what is B complement? Take a moment to list out the elements that should belong to B complement. I encourage you to pause the video now, attempt this on your own, and then unpause to check your work. To find B complement, I always begin by marking with a pencil what are the elements of B in our universal set. So B has D, so I kind of mark above D. I don't want to mark it out completely because I might need to use this set for later problems, but we can write that above with a pencil and then erase. G, mark G. A, mark A. So I've marked all the things that should not carry over to our complement because they're part of B. So the remaining elements that should go in the complement are B, C, E, F, and H. So I just write those out. So let's next consider our final question. What would, and think about how we'd read this, U, and then the apostrophe should be read as U complement, so U complement. The way U complement works is we write out what is U first, so U is A, B, C, D, E, F, G, and H. And then to find the complement of a set, you say, I'm going to take everything that's in the set and exclude it from the universal. So piece by piece, A is in U, I exclude it from the universal set. B is in U, I exclude it from the universal. Now it turns out, since we're doing U complement, every element of U will be excluded because it has to be in the universal set, but it can't be in the set that we're complementing, which happens to be U. So as we go through the process to find U complement, we realize that no elements are left over. So U complement, the complement of the universal set, is the empty set, because there's no elements that are in U but not in U, right? Because if you replace this, the complement of U, the universal set, are all the things in U, but at the same time are not in U. No such thing can be in both groups, so the complement to the universal set is always the empty set. So this is an important rule to keep in mind, and if you're not so clear about it right now, I recommend that you pause and think about it for a little bit, go back to the definition, maybe replay that section until it makes sense, and then memorize this as an important rule. The complement of the universal set is the empty set. The next set operation that we're going to talk about is the intersection of sets. To illustrate this example, let's consider that we're voting for two different candidates in a local election. Each candidate has listed 3 main campaign promises, and they're listed below. Amy's campaign says they're going to focus on spending less money, M, emphasizing traffic law enforcement, T, increase service to suburban areas, S. Okay. As a comparison, Darian's campaign promises are spending less money, so they both share that, crack down on crooked politicians, and increase service to the city. Now, based on these 2 campaign promises for this local election, how would we answer the question, do the candidates have any common promises? So the answer to that is yes, they both have the common promise to spend less money. This is the basic idea of the intersection. It's saying, look, we have these 2 different ideas or groups or sets